So let's just start defining things within the script. We don't need to know any logic about the actual structure of the files right now. So right now we just need to know where the files are located, pretty much. And we can go from there. So where are the files located? Here. So let's define a global variable that contains that information. And we'll call it like source directory, source dir. And we'll put it in a form that this program will understand, which is this little part here, backtick colon. It's a hsim in Q. Okay, let's put that down here. I just made some labels. So there's a global config and there's nothing in it. The data sources, let's say, no, I'm wrong. Let's get rid of this. Main logic, right? For now, we'll just create a function which is, say, run, and it's defined as nothing because we haven't figured it out yet. And at the bottom of the script, we'll execute the function called run. Okay, and we can load that script right now. It won't do anything. It will just first define this global variable. It will define this empty function, and then finally it will run this empty function and spit out the result to us. So let's do that. Where is it? Which one? Okay. We could do something else within run, like show source directory. And then we'll run that again. And it showed us the source directory. Now we can do other operations on the source directory rather than just showing it. Maybe show a key source directory. Let's try that. Okay. That looks useful already. That seems to be giving us a list of files contained within source directory. So let's actually keep that information, and we can do that by putting it in a variable. Let's call it files. Now, just to be safe and from experience, we want to make sure we're only processing JSON files. We need to make sure there's, we're not, this will just give us every file that's in the directory, but maybe there's some file that's not a JSON file and our program wouldn't expect that, so we don't want to include those. So we'll try and figure out, is there some code we can write that will help us filter these this list of files, this list of files that's returned from key source dir. Let's do that. So rather than just letting the whole program run and spit out a result, let's stop inside the function. So we can go inside this function and we can write anything. It can be just something that will cause an error. Okay, so what will happen now is the script will load as normal. This function will be defined as normal, and then the run will be executed as normal. So this will call the function run. And then when run is executing, first this line will run. So key source dir will be assigned to the variable files. Then it will come to here and it will try to add the symbol G to the number 2, which doesn't make sense. So the program will at this point throw an error and it will stop processing inside this function at this point. So let's do it. So we can see here there's a type error because these are the wrong types to be added together, and it's showing us this operation does not work on these parameters because of type. But that's besides the point. That's just showing us. Usually I write something more clear, like breakpoint or stop or break or something. And I will do the same thing. And the error is just stop. Okay, but the important thing and the whole point of doing that was to get inside the function. So now we're inside the function and we can investigate variables and the conditions at this point in the running of the function. So we can look at files, we can see a list of files, and now we can start trying to go about how we would solve the problem of only including files that are JSON files. So it seems like these are JSON files and they're all underscore verb. So if we want to be sure, we'll just include that. So that's probably a variable we'll want to keep somewhere. So okay, so this is probably what we want to search for in the files. So let's just try it on one example. So is this like this? And this says, yes, it is true. So is, so this isn't. And this is. Okay, so let's use that logic. So we're going to use the same logic, except this part needs to change, and it's not just going to be one file, it's going to be a whole list of files. And these are actually different types, but they're character types. They contain characters, and this function can work on both strings and symbols. These are symbols. This is a string. This is a symbol. This is a symbol. This is a symbol. And this is a string. So we have to modify this. So we'll do is the files. No. Is this string like each of the items on the left, which is files. So this is returning true or false, 1 or 0 for each of these items. And let's just count them so we can know how many files there are. 3,360. Okay. And so this tells us, well, let's see. Let's see if there's any that aren't JSON files. So there is one. Let's see what it's called. It's called convert.sh. So that's actually the file that created the JSON files, and it's in the same directory. And if we were using our eyeballs, I doubt we would be able to see that. We could miss that pretty easily. And there could be other files that are a bit different. And it could be the case that maybe our wildcard selection wasn't, maybe our matching string was chosen by me incorrectly, and maybe it would exclude files that shouldn't be excluded, and they would be returned at this point. And at this point I could update my logic to include those files if they are improperly excluded. Yeah, so this seems like a useful piece of code, but this is returning all the files that aren't JSON. We want the files that are JSON. So let's do that. So these are all the JSON files. So we'll add this logic to the code. At this point, I see a piece of logic that works, that does what I think it should do, and I usually just copy that and paste it into my script at the location where it was run. Now we have the list of files and we've defined it into the variable files. So we've updated the variable to contain only the JSON files, only the files that contain this string at the end of their name. Now next we'll probably want to pass each of these files into a new function. So that new function will start declaring up here, read file, read JSON. And it will take a variable called file, probably. And then in here we'll just put another stop point. And here we need to actually call the function. So at the minute we've just declared it, but here we need to use it. So we will pass in each file. So each of the items within this variable called files will be passed in to the function called read JSON. Inside the function called read JSON, that variable will be accessible with the name file, F-I-L-E. So let's run this code. And I'll call this stop2 and stop1, just so it's clear that it's going to be stop2 where we encounter the error before it gets to stop1. Okay, and we can look at file, which is this. So this is just the file name. We can add on the the source directory to this to get the full path. We can read it in. We can flatten this down with this function. And we can try and convert it to from JSON into a Q object, which seems to have worked. And we don't need the first part because we know it's a verb. I think every file contains that, and it's just, yeah, if every file contains it, it's not useful information. So at the minute we've got a look at the first file and what it looks like. So it's a single record table with strange column names that we should address at some point. So let's just copy this code and put it into the script so we don't forget it. This is something we definitely want to do. So we call this data. Okay, and let me do one more thing just to check. Yeah, so that .q.id just renames the column names to be something appropriate for our programming language. You know, certain symbols are have meaning in this, like this has a meaning, this has a meaning, this has a meaning. So we probably don't want to include those as the names of columns or things that we're going to type. They might be interpreted wrong by the program. So we use this function to take care of that. So at the minute I would like to actually read in each JSON file. I don't think it's going to take too long. And I want to just confirm some basic metrics about, like, I want to know, is there only one record in each file? And so what's going to happen now, we can remove that or keep it, it doesn't matter. It will never execute this line because here we can see we're pushing the result out of the function. So we're pushing it from whence it came. So if we look here, we know this runs, then this runs. And as each file is passed in, it's pushing out the count of data where data is this table that we just extracted from the source file. So it will be pushed out of this function, and we want to push it into our own variable. The result of this, the output of this, will be pushed out to the left to whatever's on the left. May it be a calling function or just a variable name like res for result. And so what's going to happen now is we can stop inside the run function at this point, and then we can take a look at this local variable called res, which should contain the results of this running on every single file. So we can see it's 111. So we want to, let's see, are they all 1? Let's group it and see what possibilities exists. And there's only one possibility, which is there is only one record in each of these files. So we don't need to treat this as a table. Let's just do first. And that will stop in here. Okay. So this is the data, and each file contains it. So let's go to the next file. Let's go to the next file. Let's go to the next file. Okay. So another thing I would be interested in knowing is if each of these key sets is the same in all files, or is that something that we need to include in the logic, that there's different forms. And we probably want to do something with this data, do some type of operations on the data, some different operations for different key values. So mood form should maybe be parsed differently than tense form, or maybe tense form and mood form should be parsed similarly because they look a bit similar. I don't know. We need to figure it out. So what I would do is return it was fine. Okay. So in some cases there's a verbal noun, some cases there's a verbal adjective, and in some cases, all forms. So this one is both. This one only has verbal noun. This one only has verbal adjective. So that's the possibility. So maybe we should get a list of these. So these are all the fields that we can expect. Let's just store that in a global variable that we can access from anywhere. Okay. Okay, let's go back inside this function and see, can we do some type of parsing here. Okay. So this seems to have ran for every single file and contains the data. So we probably want to change this. Let's make this smaller. Let's just change the console size to something a bit bigger. It's too big. Okay. So this looks good actually. Let's rename this just cars JSON build verbs. Build verb. Let's just keep it. Let's do this. You can do what you want. Let's do some messages. Let's not. Right. So now we're here. We're inside this function. We can investigate this variable res, which contains the results of this function running on every file. And now we probably want to do some type of manipulation to the values. So it looks like verbal noun, verbal adjective, adjective, whatever. So it seems like verbal noun and verbal adjective are similar. Yeah, so let's do some type of operation that applies to those two only. So let's apply to res at both verbal noun and at verbal adjective, and apply this operation to the values. Keep doing the same thing and expect different outcome. Let's try it. These look better. And some of them might have 2 records. So let's just check. So you can see here, we have 2 strings for the verbal adjective for this verb. Which is good, we didn't lose information, which is important. And this one should still be null as it was. Okay, so let's do these ones. They're both everything's a table. Okay, let's keep going. Okay. These are tables. Let's just extract them from. And okay, but it looks like we can just join this onto the bottom, you know, sequentially onto each other. Oh shit. Right. So okay. We should do that differently too. Oh. Okay. The 188,076 records. Okay. And then, okay, let's do this. So we need to flatten the result. Yeah, we should probably do this a different way, but we're not getting paid for this, so let's keep going. Well, let's time how long it takes. Let's add some messaging. And getting source file. Right. We could add messages after too. And then inside this one, we'll just display. We'll not use -1. -1 includes a new line. 2 does not include any spaces. So we'll just add a single dot every time read JSON is called. So that will be before, and also after each JSON file is processed with this function. So let's run it. Okay. Silly mistakes. String. No. Okay, it's working. So it's quite quick, but getting source files from source directory. Find files 3,360. Filtering files, only JSON allowed. Find JSON files 3,359. And then it did this, and it did a dot for each of the 3,360 files. Then it said complete it. There was no new line because 2 printed out the last dot, so we'll add a new line to the start of this one. And then it showed us how much time it took. So it took 1.9 seconds in total. Okay, 1.7 seconds in total. A new record. Right. Now we have the results. And we'll probably be doing searches by verb, so on this particular column here. So if we look at the table, say, you can see here there's no, we can add an attribute to this column which will make queries faster. So let's do that. So apply to the table at the verb column and make it have a parted attribute. Right, and let's just actually, well, let's save this somewhere. So let's find an appropriate location. Right, let's just do it here for now. And that will be another global variable. Okay. So now we want to save it to disk. So we have this new variable, and we'll save the file, the table there. Let's just call it verb forms. Verb forms. So that's the path, and we want to set our table, which is called res. Okay, so that saved down our table to this location. Okay, so that's done. So yeah, let's look at the table. So we don't need to run build verbs anymore. Let's comment it out, and instead we will just load the table. So let's load, save to. And so remember, we're not building anything, we're not running any of this code, we're just defining, when the script is going to be loaded, it will just define the functions, but it won't actually run them. Only this line here will be ran. So now verb form should exist, and we should be able to query. Yeah, that's about it. So I think the whole point of this is, let's look at what we came up with. We've got code that runs on 3,360 JSON files and converts them into a single queryable data structure. And at the start we didn't really know what logic we would contain, what logic the script would contain. We just created empty functions and defined things that we knew we needed or might need, and kind of iteratively came to a solution. This isn't the best. I'm sure we could spend more time and to make it more efficient or whatever we'd like to do, but it's doing the job that we want it to do, and this seems like it's useful data that we can include in our project. So I think that'll do. Good luck. Slán.